would probably be like 1.5 marks. It would make up the majority of the marks. And actually, that's how the assignment grading is going as well. The interpretation is always worth more than the actual calculation. Yeah, exactly. So that's a great way of putting it. So if we were to draw this out, what it's saying is that the value 215 is 1.3 standard deviations above the mean. So if the mean is equal to 180, then what this is saying is 180 plus 1.3 times the standard deviation is equal to 215. So you can think of it like this, or the way you should think about it, like what your final statement should be is that 215 is 1.3 standard deviations away from the mean song length. Or maybe I'll write it out in the chat for everyone. Okay, so that's how you would interpret the z-score. If your z-score was negative, you wouldn't say above, you would say below. So that's question 2. Now, question 3. So essentially, what this problem is asking is saying, what is the probability that the z-score, so the probability, and if you guys can't see that, let me write in black actually, the probability that the z-score is less than 0.4 standard deviations above the mean. So in other words, what that's saying is the probability that z is less than 0.4. So that's only true when your mean is equal to 0 and your standard deviation is equal to 1. But that's not for a normal distribution. You're thinking of a standard normal distribution. Yeah, standard normal. So essentially, what this problem is asking is saying, what is the probability that z is less than 0.4? Now, does anyone know how we can calculate this value? And I think on the question it says use a table or use salt, and I wouldn't recommend any of those. So if you haven't already, I want everyone to load up your R, because we're going to be using R from now on. Well, I might not, but I want you guys to write your calculations in R. So I'll give you a minute for your R to load up. And start off with a fresh new script. I'll load up mine as well. So, and what we have here, so if this is our normal distribution, right? It's a standard normal, so we are centered at around 0. And we want to find the probability that we are less than, let's say this is 0.4. So we want everything that comes before 0.4. So is anyone familiar as to how we can calculate this? Right, so we're going to use the Pnorm function. Yeah, the question said above the mean, so that implies that your value is a positive 0.4. It meant it still said what it less than. So yeah, it would say would be less than 0.4 standard deviations above the mean. So less than 0.4, yeah, but because we're above the mean, it's a positive 0.4. So I want to now show you guys what this pnorm function does. So the pnorm function of, let's say, if this is our new table, right, and we are centered at a mean mu, doesn't necessarily have to be 0. So if I ask you, what is the probability that z is less than some value b? Okay, so what pnorm does is pnorm gives you this probability. So pnorm of b will give you everything. So let's say this is the point B. It's all the way over here now. Pnorm of B is going to give you the entire area to the left of B. It's giving you everything to the left of B. So if you want to calculate the probability that Z is less than B, all you're going to apply is Pnorm of B. Except you need to make one consideration. So going back to our question 3, all you would write here, like the R code you would write is pnorm, and this should be a lowercase p, sorry, pnorm of 0.4. You write this is going to give you the correct answer. Okay, so if we all write that in our R console or script, pnorm of 0.4, what you should get back is 0.655. So that's the answer to question 3. But I want to make a further note for what the pnorm function does. What you have to also specify is the mean and the standard deviation. So pnorm, pnorm automatically defaults to a mean of 0 and a standard deviation of 1. If you don't set any parameters, if you just write pnorm of your number, it's going to assume you're giving it a mean 0 and the standard deviation of 1. So in this case, it told us that our mean was 0 and our standard deviation was 1. So we didn't necessarily have to specify that. But over here, I said, hey, we don't know what the mean is. All we know is that the mean is equal to mu. So let's say the mean was equal to 5. Okay, so the mean was equal to 5, the standard deviation was equal to 3. So what you would then have to write here is pnorm of b, and then you'd say mean is equal to 5 and standard deviation is equal to 3. So because this wasn't a standard normal distribution, you have to specify what the mean and the standard deviation is for R. If you don't do that, it's going to assume the mean is 0 and the standard deviation is 1, and you're going to get a wrong answer. I've seen this happen before, so don't make this silly mistake. Okay, so again, pnorm gives you everything to the left of your area. So, for example now, what if I said for a standard normal distribution, it's a pretty bad graph, I want to calculate everything that comes to the right of 1.2. So what is the probability that z